Hello friends, I am Shamli. Today we shall discuss on topic sorting of large files into disk. The concept I am going to cover in this video are process of sorting and solution of sorting problems. Further, we will see the parameters of improving performance of sorting in which sorting time, sorting large files, replacement selection and multi-step merge will cover. First of all, we will see the introductory part related to sorting and its type. Sorting is nothing but storage of data in sorted order. It can be ascending or descending order. An internal sort is any data sorting process that takes place entirely within the main memory of computer. This is possible whenever the data to be sorted is small enough to held in main memory. External sorting can handle massive amounts of data. External sorting is required when the data being sorted do not fit into main memory. If a file is too large to be sorted in main memory, then it has to be sorted on disk. Now we will see the actual process of sorting large files. The multi-way merge provides a solution to the problem of sorting large files. Consider file with 80 lakh records. We can create a sorted subset of our full file by reading records into main memory until the memory work area is almost full. So, these unsorted records can be separated into 80 internal sorts as follows. Then, writing the sorted records back to the disk as a sorted subfile. This sorted subfile is a run. Hence, we have the 80 runs in 80 separate files on the disk, and we can create the 80-way merge of these records. Then, using the multi-way merge logic, we create a completely sorted file containing all the original records. After process, we will see the solution of sorting problems. It can see large files and can extend it to the files of any size. Recording of the input file during the run creation step is sequential and hence is much faster than input required seeking for every record individually. Steps can be used if necessary for both input and output operation as input output is largely sequential. Reading through each run during merging and writing the sorted records is sequential. Runtime accesses are required as we switch from run to run during the merge operation. After completing the introductory part, we will move to the parameter improving the performance of sorting. First is sorting time. While sorting, input output is performed 4 times. It contains sort phase and merge phase. During the sorting phase, two operations perform. Reading all records into memory for sorting and forming runs and writing sorting runs to disk, and during the merge records, sorted runs into memory for merging and writing sorted files to the disk occurs. Second parameter is large files. To sort a file that is 10 times larger, we need to do more seeks on disk. It takes approximately 2 hours and 6 minutes to merge sort. The third and most interesting parameter is replacement selection. Replacement selection is method of creating initial runs based on the idea of always selecting from memory the record whose key have the lowest value. This replacement selection can be implemented in 3 steps. In initialization step, reading a collection of records and sort them using heap sort. In replacement step, instead of writing the entire primary heap. In sorted order, write only the record whose key has lowest value. Then bring in a new record and compare the value of its key with that of key that has just been output. If the new key value is higher, insert new record into its proper place in the primary heap. If a new record's key value is lower place, the record is secondary heap. At last, in merge step, repeat step 3 as long as there are. At last, in merge step, repeat step 3 as long as there are records left in the primary heap and their input list of 30 keys. In order to sort the keys using replacement selection, we have to consider three columns. First is input, second memory work area that can hold only 3 keys, and third is output run. So, first of all, we begin by reading the keys, the 3 keys into memory, then fit there and use heap sort to sort them. Then we select the keys with minimum value, that is 5, and output that key. Now we have a place in memory for further key. So we read one from the input list, which is at the rightmost side. The new key, which have the value 12, now become a member of set of keys sorted in input runs. Then compare the three values in memory, that is 12, 47 and 16, and see which is the smaller one and that should have the highest value, which is in output run. So 12 is the second new key, that is output, and 67 will takes place of 12. Again, we compare the values in memory, that is 67, 47, 16, and 16 is the next key, that is output, and 21 will fill its place in memory. Then after comparing 47, 67 and 21, 21 is the next output key which is going into run, and 7 will fill its place. After checking the smallest value among 67, 47 and 7, 7 is the smallest value as it is a smaller last and mark is as belonging to the next run. 47 is the next key output and 17 will fill the place. After that 17 and 14 also be the part of next run as it is smaller than last output, and 67 will be the next output key. Hence, the first run completes as marked elements reaches the top of memory. In second run, one by one, we sort and display the output regarding to the comparisons as we done in the first run, and finally we get sorted keys. And the last parameter is multi-step merge. Multi-step merge is a memory merge in which not all records are merged in one step. Rather, Rather, several sets of runs are merged separately. Each set consists of the records from all its runs. These new longer sets are then merged either all together or in several sets. Please try to solve the following MCQs as you see the video.